Hi everyone, welcome to Startupification, a podcast about how technology is changing the world around us with me, Matt Ferrugia, and my co-host, Stephen Drost. You can find out more about us, browse all the episodes, and view the show notes at startupification.fm. And if you want to follow us on Twitter, Stephen is at DrostyBoy, I'm at Matt Ferrugia, and the show is at startup_FM. Hi everyone, it's Matt. This week, Stephen and I are discussing the innovations introduced by the new AI model known as GPT-3. It's a real philosophy technology crossover topic, this one, as this development holds some fascinating potential along the path to human-like machine output. We'll talk a bit about the people and the company behind it, how the technology works in simple terms, and some of the examples that people have started producing with it. We'll also dive into some deeper chats unpicking what it means to produce intelligent language output and what the knock-on impact might eventually be from technologies like GPT-3 on future jobs for developers, designers, data scientists and others. I hope you enjoy the show. Hi Stephen, how are you?
I'm good, Matt. How are you doing?
I am excellent today, thanks very much. And I'm excited to talk about a topic that has become all of what Twitter has talked about through the last month or so. Do you want to tell us what that topic is?
Yeah, we're going to be talking about GPT-3. And I'm not going to define it any further than that for now. But yeah, you're right. Developer Twitter, we should say, has
Sure,
been
yeah.
all ablaze with talking about this. So it's a very exciting topic. And it's one, I'll be honest, where I'm going to let you talk more than me today, because I think you know a lot more about it than I do. But I'll just come in from the side and ask weird questions.
I don't know a huge amount about it, but I know a bit about it, and it has a nice philosophical angle. So I think we can have a nice, exciting back and forth, probe a little bit, and give people a general background and also some of the more interesting areas of it. That's going to be cool, right?
Yeah, I think so.
Let's do it.
Cool. So I'll just give a tiny bit of a background then to GPT-3, and we'll take it from there.
Do it. Tell us what it is.
So there's so many kind of long-winded, difficult definitions of this. So I thought I'd be a little bit more playful. And I read in an article the other day, someone referred to it as the ultimate autocomplete tool, and I really liked that. So I guess it's kind of like a tool, an AI tool that has looked at lots and lots and lots and lots of words. It's a natural language processing tool. And having looked at all of those words, you can use it to make predictions to create text. I think that's the most basic kind of definition of it.
Yeah, you're totally right. So basically you type in something and then it predicts what will come next. Yeah. And that's the general thing it does, and it does it in lots of different specific circumstances we can talk about. But why don't you say who makes it? Where does it come from?
Yeah, that's a very good point. So it was made by, that's the thing. It's a company, a group of people, a not-for-profit, for-profit. That's something we could do a whole episode on, frankly. But it was made by OpenAI. OpenAI, many people might know because it's a kind of supergroup, kind of all-stars, Silicon Valley company. It was, I guess, created by Elon Musk and Sam Altman as the most prominent figures, but Peter Thiel's in the mix. A whole bunch of Silicon Valley stalwarts are there. And so they set up this company. Again, people might have heard the whole piece around fear of AI. So particularly Elon Musk talks about this a lot, the kind of Skynet fear kind of thing. And I think the original idea behind OpenAI, as the name would suggest, is that you bring together a bunch of clever people who are sort of not necessarily profit motivated, although we can question that, and they create a kind of open AI piece that's got some kind of ethical governance around it, some kind of openness. I guess, does that sound okay to you?
Yeah, I feel that the kind of openness, ethical bit is maybe overplayed. I don't know. I mean, it's definitely a bunch of Silicon Valley superstars. I like to think of it as the Avengers Initiative equivalent of Silicon Valley people all being brought together. And definitely Elon Musk was involved at the start. He's no longer involved. I think he took a step back because he felt there was a conflict with what Tesla were doing with their AI piece. But it was, they founded it with, I think it's like $1 billion worth of investment from the various parties. So it was heavily funded. And what they released in the early days were things like a kind of reinforcement learning playground, so that people could kind of experiment around reinforcement stuff. But it's not like it's not like an open source project in the sense that they're just doing things out in the open and anybody can do anything they want with the codes and it's completely unrestricted. And I don't know if that was always the vision, but certainly the tune did change a year or so ago, right?
Yeah, I mean, a potted history, and it's quite difficult to work out. I've seen so many conflicting sort of versions of this, but I guess it's based on a bunch of code that Google created, and then they created GPT, as you would imagine, 1 and then 2 over the last couple of years. And the story is that basically we get the new version numbers, they're based on being a lot bigger, so far many more words being ingested into the system. From the one thing, and then the second thing is that the parameters of the model are massively inflated as well. So we've got those two kind of bigger, this thing's growing essentially. And honestly, the business model piece is really kind of unclear to me as well. It looks like they're doing something fairly innovative, in as much that it's really hard to describe what it is. But they've gone through kind of moments of being a kind of not-for-profit, and now I guess they're kind of for-profit. As you said, Elon Musk kind of stepped back, but Microsoft's part of the mix now as well. So it's all a little bit mysterious in that sense.
Yeah, I mean, Microsoft came along last year, I believe, and put a further $1 billion in, and I don't know how much they tied up, but basically it was a kind of an agreement whereby they would be able to use some of the outputs from OpenAI. So at that point, there are two legal structures, I believe. There's a not-for-profit parent, and then there's the kind of commercial piece that this is being that's offering the API, and that's the thing that's kind of new right now, is that they expose their GPT-3 model, which we'll talk about what that actually means in a second, but they expose it via an API, and that API is in beta just now, but will be a commercial API eventually, right?
Yeah, exactly. Matt, we're always trying to iterate this podcast, and it's a kind of open thing that you and I discuss a lot, is that we're thinking of doing sort of interviews in the future. As a weird kind of practice run, I'm not going to go as far as interviewing you, but do you mind if I ask you just some questions about GPT-3?
I wouldn't mind if you'd prepared me in advance. Yeah, go for it.
Spontaneous.
Please do it.
No, I'm just thinking. We've spoken about this stuff privately a lot, and you just know a lot more about it than I do, and you've been frankly able to explain it really well to me. So I thought I could maybe just build on that a little bit.
Do it.
So, raising that much money, what do you spend your money on when you're building GPT-3?
That's a good question. I mean, that's not the question I thought you'd ask. I thought you'd ask me a technical question, like what does the T stand for? That was more what I was hoping for.
That's an even better question. So Jesus, you're giving better answers and asking better questions. So what does GPT-3 stand for, Matt?
Yes, one I can answer. GPT-3 is the third iteration of what is called a generative pre-trained transformer. That's the three letters there. So what is a transformer? Okay, so in general, natural language AI models, they've been built to be kind of task specific. So you might get something that's built in order to do translation, or you might get something that's built in order to do some other task. But the way that they have kind of worked in the past is that they're trying to guess what word to give you that makes sense within the context of the task you're trying to perform. So in the case of translation, you give it a French word and it tries to tell you what the right English word is. And the way it's happened historically is it's typically been done not exactly word for word, but pretty much you can think of it as word for word. So you get one word and then you do the next word, and they get passed through from kind of like left to right in a process through this model. And what transformers do, which is kind of radically different, is that they look at, you can think of it like a sliding window across lots of words. And in the case of GPT-3, it's something like 2,000 words. So it's going through the sentences en masse and trying to work out basically what word is correct from the context of the other words around it. And that transformer approach, as opposed to, the thing it replaced was what was called recurrent neural networks. The transformer approach is the thing that has been, Google were here at the start. I think they invented transformers. I'm not sure that OpenAI is using their code. I don't know. Right now, you can think of OpenAI as kind of the opponent to the DeepMind organization. They're kind of an AI research group, and so DeepMind is Google's, and OpenAI is the rest of the Silicon Valley people. So how much overlap there is, I don't know. But that's
just to fill that in. Transformer is literally the name of the algorithm that Google created. So it's literally based on.
Yeah, and it's a style of model. You get lots of different styles of natural language, machine learning models, and a transformer is a particular approach to doing it. You touched on this before. Pre-trained means that they feed lots and lots of words into it and generate the model out of it. So again, the traditional approach would have been that you take a task-specific thing and you feed it in your kind of special data, and your special data retrains the model, not from scratch. I think we talked about this when we talked about the cookie detector, right, way back in one of the your favorite cookie detector story about machine learning. So the cookie detector, we explained back then that you could turn something that detects cookies into something that detects cancers by basically taking off the last layer of it and retraining it with your pictures of cancers. And all the other stuff it's good at, like detecting edges or however it does it, patterns, suddenly becomes applied to that problem, and it can classify melanomas instead. That's not how these generative pre-trained transformers work. You have one model that gets kind of built from analyzing really lots and lots of data. Now, in the case of GPT-3, I'm not sure it's public, but the story that's going around is it's basically been trained on 500 billion words. And for context, Wikipedia, I've heard, is 0.6% of its training data. So it's a lot of text, right?
It's huge.
Yeah. So that's what the transformer part is.
Okay, so let me jump back in with another amazing question. So I think that's a good and probably good enough technical description of what it does. But back to the other brilliant question I was thinking of, what would you spend all that money on? So what does it look like? What's it look like to run something like this?
Yeah. So
what do you need?
Yeah, honest answer is I don't know, but what people have talked about they spent a lot of money on was actually building. It's like how do you win? Well, what's been very topical during lockdown is how do you win the NBA championship with the Chicago Bulls? And where you start with that is you have to build your team. And so I believe a lot of money was spent on pooling together, not huge numbers of people, something like 7 mega superstar AI researchers were brought together. Is that what you'd heard too?
Yeah, I'd even heard, the ex-Stripe CTO. So yeah, people like her kind of the sort of world-class superstars in that area. So yeah, I guess paying them costs a lot of money.
Paying them does cost a lot of money. I mean, it doesn't cost $1 billion. Yeah. Obviously, you have to do a certain amount of compute power is required. So that's one thing is a lot bigger GPT-3 than previous versions of this type of architecture we've seen. So GPT-1, which was 2018, which seems kind of recent, but in this world is not recent at all. That was trained with 117 million parameters. What we mean by parameters, you touched on this before. It's a little bit like when you encode the words, you have to turn those words into basically numbers, and then those numbers get multiplied together by weights through that's how neural networks work. So you just do lots and lots of multiplication, but the kind of how broad that sequence of numbers that you encode, effectively the string of words into, how broad that is your number of parameters. So GPT-1 was 117 million parameters, which is a lot, right? Each of those parameters are connected to all the others, or probably not all the others, but you can sort of think of them as like, one parameter multiplied by another parameter via some weight gives you the output, and then you go to the next layer and you multiply them together, and the next layer you multiply them together. So if you're knocking around with 117 million parameters inside that neural network, that's a lot of multiplication having to be done by the compute. So you need effectively a lot of computer power to do it. So that was GPT-1 in 2018. GPT-2 in 2019 went from 117 million to 1.5 billion parameters, which is, that's a big jump.
10x,
yeah. And then GPT-3 did 100x because it jumped up to 175 billion parameters. Now, by the time you get to doing that number of multiplications together, I mean, computers are really fast at doing calculations, but these are a mind-bogglingly large number of calculations. And that's effectively how neural networks work. That's thought to cost, each time you train that model, it's probably $10 million worth of cloud compute if you were to do that just by buying Amazon Cloud Compute to do something similar. And they're obviously training that model lots and lots until they get to the point where it's actually quite good. But the thing that's really interesting is once you've got it to that point, you don't then retrain it for every single example that you want to try out. You use basically that one model and you adapt it for the next example. So I would think there's some combination of people and compute power is where they're spending the money. There we go. It was always going to be that though, wasn't it? That was always going to be the answer.
Yeah, it was. Well, but still, it was nice to hear I thought it would be an interesting way to ask the question to get lots of other information from it. Subtle like that. So thanks. That's a lot clearer to me.
Right, I'm gonna ask you a question back, right? Since we're doing this, right? Where do you think the balance of, in terms of, it's obviously producing some successes just now. We talked about some of the combinations in people are the world leading AI researchers plus the CTO of Stripe. And I don't think we talked about the CEO is a guy called Sam Altman, right? So you can talk a little bit about who Sam is and what he brings to the party. So here's a question back for you. Okay. From their success, do you think it's more driven by those what's rock star AI researchers or by the rock star C-suite?
I'm going to cop out and just say it's a kind of synergy between the two. I think it's really driven, or certainly I think it's, if I'm being naive, I think it's driven in the first instance by painting a picture of the future and looking at what AI could do, and a group of people thinking, well, we don't want AI to do certain things, so we should all group together and almost a little bit ideologically say, this is what we think AI should look like. And I think that's been on the level of investor types and people who know how to build companies, but also on the individual level of people who, that I've read, I don't know how real this is, but I've read that people have sort of forgone a lot of higher earnings they could get working for other companies and joined OpenAI to sort of do the right thing, quote unquote. So I think that's kind of how that happened, to be honest.
Yeah, I think there is something in that. I'm generally a little bit I'm cool on that whole idea that the leadership can make that much difference. But Sam Altman's a pretty smart cookie, right? Do you want to talk about Sam for a second?
Yeah, sure. Yeah, no, Sam's definitely super smart. Sam, until very recently, was the main man at Y Combinator. So as such has been, around the startup and the scale up and the exiting for billions of dollars world for a long time. And I think, Y Combinator has a particular vision as well, which is essentially there's so many parts to it, but there's a strong educational bent to it and a strong idea of enabling lots of people and widening the map away just from being in San Francisco to, startup school and trying to source smart people all over the planet. So I think Sam's bringing that to the game. And also the thing that fascinates me, and I just don't know enough, Matt, unfortunately, is I just think there's going to be some kind of business model innovation here that's going to be very, very interesting. Because as you alluded to earlier, it's not going to just be here, despite the fact that we're called OpenAI here, it's not just going to be here's access to the code, but instead, frankly, the impressive thing we're seeing is the API in action from GPT-3. So monetizing that in some way, and making that a kind of commodity play, or maybe not a commodity, I don't know, but some kind of tool that startups can use or other companies can use, I think that's going to be really exciting.
Yeah, do you know, it's ironic, I hadn't thought about it before, but they're probably better called closed AI than OpenAI because the standard approach is that you just give away the model here, or you give away a reference to this model, and they haven't done that. Now, even back in the GPT-2 days, they also didn't do that, and the reason they said that is because by the time GPT-2 came along, excuse me, I put my teeth back in every time I say GPT, that was already they could see that it had the potential to generate stuff that could be underhand, duplicitous, and could basically seed the internet with a lot of fake text. So they already at that point said we have to control what we're doing. And so when it came to the whole idea with this beta of the API is that they're saying actually we don't want anybody to use this for any reason. We're going to make sure that we're the gatekeepers.
Yeah,
there you go.
Absolutely.
That classic thing, isn't it?
It is. Absolutely right. And which and we can talk about this later a little bit more, makes OpenAI such an interesting company philosophically, because you've got the actual kind of machine learning AI piece around it, which is super interesting, and we'll talk about that, about how realistic that text looks and how it could be confused with human created outputs. But then you've also got this intense ethical moment of who guards the guardians. So I completely agree. Do you want to give some more texture as to what OpenAI, or what GPT-3 rather, can kind of create?
Sure. Yeah. Well, the best way to do that is we probably talk about some examples, right?
Yeah.
So let me. So around July time, a lot of examples started to emerge onto the Twitter sphere as people were let into the beta program. The actual paper for GPT-3 was published back in May, but it took a couple of months until they let people use it, and then suddenly it became this kind of moment where it was like viral explosion on social media, where if you had a cool example, you could get people to retweet you within, I guess, dev Twitter or whatever. And then the VCs kind of jumped on the back of that because they kind of thought this all looks exciting. So what was the first example? What's your favorite example out of them? Let's just go through some examples.
Okay, well, I'll go with the first one because it's not my favorite, but it was a kind of interesting one. It was basically just taking almost coding with GPT-3. So it was kind of using sort of natural language as a kind of code input, and it was saying, I think it was like jQuery or something like that, where people would just say, hey, build me 5 buttons and make them, whatever color, whatever shape, whatever size, and label them the following ways. And then boom, you would just, describe that, and then the computer would just give you that as a model. And that looked really, really interesting.
Yeah, I think that did look interesting. That was the first one I saw as well. It was a guy typing in, show me a button that looks like a watermelon for some odd reason. And then out popped a button that was round with a pink inside and a green outside. Yeah. So that was one of the first ones. Honestly, when I first saw that, I thought that was fake. I thought that was someone just pretending. In fact, that's my kind of journey, has been some of the first examples I assume were fake. Now I assume that we're only seeing kind of cleaned up outputs, or maybe even that what we're seeing is just mega constrained. But they have been very, very impressive. I mean, other things, so that's kind of one class of thing you've seen where maybe let's sidebar a little bit as to how that, we've been talking about text generation. How come you're talking about coding now? Well, how does that really work? Well, the reason that this kind of works is because the transformer, what they allow you to do is they're not just, they have what's called a few-shot model. So essentially, once you've got your kind of model that understands how the internet talks to itself, or how documents on the internet are written, what it's then able to do is you prime it with a few examples of what you want it to do. So in your case with the code, that person will have said, okay, if I say to you something like, show me 3 buttons that look like a football, a tennis ball, and a basketball, then they will actually supply code that has a white and black button, a yellow button, and then an orange button. And they have to prime the system with that, and then they say, and now show me a button that looks like a watermelon. And what GPT-3 is doing is it's saying, well, like, I understand the concept of,
Show me a button.
Show me a button. I know how to do that because you gave examples of show me a button, and I can figure out that when you're giving me these words that like are football and watermelon and basketball, I need to set the right color for that button. So I'm doing the context of your question like a watermelon. You're basically saying to me, make it the color of a watermelon, and from all the stuff I've read, I can tell that a watermelon is pink and green on the outside, and that's kind of what it's doing. But what's interesting is that we didn't retrain it with all that code. We gave it 3 or 4 examples of code, and then given those 3 or 4 examples only, those few shots, it's able to then say, okay, yeah, I can solve the task like a button that looks like a watermelon, no problem at all. So that's a kind of technical extra bit that makes these examples possible. Other things I've seen, which you see a lot of stuff where it like a chatbot that speaks like Bertrand Russell, right? And there's a lot of that stuff, right? You've seen it basically show me content that is in the style of someone else. You must have come across some of that.
Yeah, exactly. Yeah, I saw the Bertrand Russell thing as well. It's super interesting, and there's a lot of, I guess, if you take it to a certain degree, that kind of spoofing human styles, or, well, it's a hop, skip, and a jump away from spoofing a human in general. So I guess there's a kind of Turing test quality to this stuff as well, that's very, very interesting. You can see that it's getting better and better at this. Let me ask you, do you think, what are your thoughts on the Turing test, and what do you think GPT-3 does for the Turing test?
Yeah, I mean, I've seen people specifically answer this question around the Turing test. I can't remember the name of the person. That will come back to me. But somebody did a paper or an article on this, effectively trying to recreate the Turing test with GPT-3. And they found that the way to get to the answer wasn't by doing the stuff that we traditionally do just now, which is to ask it kind of like real type questions. It was to ask it nonsense questions. It was Kevin Lacker, that's who I'm trying to get to. So if you ask it questions like, what's human life expectancy in the United States, it's very good at answering human life expectancy is in the United States is 78 years. Yeah. Stuff like that. Even better than that, here's a better example. Who was president of the United States in 1955? And it will say Dwight D. Eisenhower was president. And then you can ask it, what party did he belong to? And you can say he belonged to the Republican Party. So it's got that context. And that was the traditional way to try and spoof the Turing test, was to try and do kind of logical connections through the conversation and see if, quite quickly that used to break down. Well, GPT-3 is very good at doing that. That's our transformer piece. It's got the context is very good at kind of disambiguating when you say what party did he belong to.
Yeah, it's a political party.
You have to know that, right? And you have to be able to follow context to do that. However, if you ask it stuff that's garbage questions, then it won't say that's a garbage question. So the examples he gave, here's one: how many rainbows does it take to jump from Hawaii to 17? And it says, it takes 2 rainbows to jump from Hawaii to 17. Now, that's total nonsense. And then anybody would say it's total nonsense. And it kind of comes, I think we've talked about this before between the two of us. I kind of, people love Alan Turing, rightly so. And I kind of think people have a real kind of fondness for the Turing test, but I'm just not really sure it's got that much validity anymore. I mean, what's the point of the Turing test?
Yeah. No, I know. We've spoken about this a lot privately, I guess. Look, for me, I think the Turing test was just very much of its time. And it was, you were starting to postulate AI, I guess, roughly around that time, from the 50s or so. So it's even before the sort of first postulations of AI. But I think you were just, that was the way you were able to phrase or hint at what an emergent artificial intelligence could look like, i.e. could it seem to you as a human being if you didn't see it, if you just sort of like passed notes with it. I think that was just the metaphor of the time. You're probably right. That probably needs to be updated, and I think there's a bunch of people who are updating it. The thing that fascinates me philosophically, if you say how many rainbows, I hadn't seen that example, but if it takes 2 rainbows to jump from Hawaii to 17, that can be gibberish, but you could also imagine a sort of whimsical comedian doing that as a joke.
It's very deep.
No, I just think you could imagine it, right? You can imagine, I don't know, you can imagine that being on The Mighty Boosh or something.
But
showing my age again here. But you could, right? That's the kind of thing that, this is precisely the kind of joke that these guys would make. And I wonder if there's almost like a sort of weird continuum where you think that humans are obviously meaning and pattern seeking and meaning and pattern outputting on the one end of that continuum, and on the other end you've got computers that can't do that. And I wonder how true that actually is. I think the more
Yeah, I mean, you've hit this is the thing that's philosophically so interesting about this. I mean, we didn't talk about this when we mentioned OpenAI earlier, because as well as having that kind of ethical, it shouldn't be kind of closed sort of view, they're really focused on general AI. Now, general AI, which is an AI,
it's a philosophy of mind question, right?
Yeah, it is a philosophy of mind. Yeah. And general AI has for many years been thought to be quite far away. And nobody, if you'd ask somebody in 2018, when are we going to have a general AI? In fact, if you ask somebody in January of 2020, when are we going to get a general AI? The answer would be no time soon, right? Because these things are garbage. Like on the happy path, they're like super great, and they can look really impressive, but under the hood, this is like it doesn't know anything. It doesn't have any sense of meaning at all. What I think GPT-3 has done is it slightly changed the game in a couple of ways. One is that it's become much better at doing stuff that sounds right. And two, I think it's raised the question of what does that, if it sounds right most of the time, what does that actually mean? So I'll give you my favorite quote on this on Twitter, which somebody sent me this way right at the beginning. Somebody showed me the example of the watermelon, and my response was to look down that tweet thread and see this person's comment, and which is exactly what I thought at the time, which was the GPT-3 stuff is a meaningless word salad that happens to be grammatically and thematically correct. And I thought that's probably about right. But I even said this at the time to the person. The problem is most of the clever sounding stuff that humans spout on Twitter probably also fits that definition.
Yeah.
And when you take a step back and think about that, it's either GPT-3 is very close to some kind of general intelligence, or we're just really easily tricked. As somebody smarter than me said, we're easily tricked by the epiphenomena of thinking. I don't even know what that means, but you probably do. Sounds clever.
Yeah, I think one of the ways to sort of get into that conversation a little bit more deeply is to look at the fact that GPT-3 can apparently basically do arithmetic as well, and that's the kind of crazy thing. There are some limits to it, but do you want to talk about the arithmetic of what GPT-3 can do?
Yeah, well, apparently it can do arbitrary 2-digit arithmetic. So I mean, I guess that's everything that as multiplication and division, 2 digits, so 25 times 37, it can give you the answer to that. And the question is that has that emerged from as a kind of higher level concept of understanding, or is it just this is it performing one subset of the task of text prediction, where it happens to have been trained very well on 2-digit arithmetic?
Yeah, I mean, exactly. The mysterious thing is that it can do it with 2 digits, but it can't do it with like 4 or any more. But maybe it is emergent, and it brings you to that kind of thing of like dog arithmetic, where you can sort of ask a dog, what's 5 plus 5, and then have it bark 10 times by teaching it to do that. Yeah. And then saying, well, that's not actually arithmetic. But if you apply that to human beings, you're looking at the kind of outer limits of knowledge in a weird way, and just saying stuff, not equating to knowing stuff. And if you look at that, you can look at something really, really difficult, like fourth dimensional mathematics or something, and you've maybe got a couple of hundred people on the planet who can converse with each other with it, and even there you might have some imposters. I don't know, but it just opens up this question of what does it mean to know something.
Yeah, I think you're right. I mean, that's this difficult part of this, is that humans actually aren't that good even at 2-digit arithmetic. And certainly we don't use our language understanding to do 3-digit or 4-digit arithmetic. We have another strategy. So we may not be better because we can do this via another route than GPT-3 is. It might be just as intelligent in this stuff. It's hard to know. The one that kind of slightly made me take a step back was there's somebody called Melanie Mitchell. She has an article. She studied in the past what's called copycat letter string analogies. And this is a little bit, this is not the greatest thing to talk about, but let me just talk about it quickly because I think it is interesting. So her examples that she fed to GPT-3, the first one she did was, if ABC gets changed to ABD, then what does PQR get changed to? Now the answer to that is PQS. The thing about humans is, analogies is one of the things we can do with zero-shot learning. That's the basis of being able to do an analogy. You don't have to spoon feed 2 examples to get example 3. The whole point is that you can make the analogous leap straight away. That's what an analogy effectively is. So she did this, and initially the fact that it could do that one, it did get PQR to PQS. But when she did a decent analysis of it, she found that it couldn't do. The results were mixed. So it could do some things and not other things. But the fact that it could do any of those analogies is slightly surprising. That does look like, and there's been a couple of other emergent patterns in linguistic stuff. So, olive oil is oil made out of processing olives, and it's able to apply that to other stuff. Those type of linguistic patterns, and certainly the letter string analogies, that looks like a higher level emergent concept than just brute force context analysis.
Yeah, we're back. Yeah, syllogistic reasoning, right? It's scary to contemplate. Yeah, another. Yeah, we could talk about that for hours. I'm realizing there's more philosophy than just the kind of philosophy of mind piece that we're kind of very briefly dipping our toes into here. There's more than the ethics piece, or maybe it's a second ethics piece rather. Or maybe it's like a sort of political philosophy piece. Because as we're looking at all these different things that GPT-3 can do, I mean, one of the obvious kind of questions is, what are the consequences for society for this? Mm-hmm. I mean, I've seen all these kind of Figma plugins and stuff where people are starting to say, well, is this the end of developers, right? Are we going to use this kind of stuff to displace developers, or will developers have a different job in the future? At the moment, developers kind of code and do that stuff themselves by thinking, and they have a certain sort of input mechanism where you sort of type code essentially, and you're very particular about which tool you use to type that code with, and how you annotate thoughts essentially. And we sort of call that coding. You and I spoke recently about NoCode tools, where you're kind of making that process a little bit more sort of beholden or shaped into a kind of graphical interface, where you sort of drag and drop things along. So you're still doing this sort of thinking, but you're not coding as such. You're being more visual. Do you think there's a world where these kind of AI solutions, be it GPT-3 or something else, is starting to hint at a world where those kind of tools will be more dominant, and the jobs of human developers will be more about debugging stuff? What are your thoughts on that?
No. I mean, you asked a very subtle question. So I mean, I wanted you to ask like, will these replace developers? I mean, the answer for me is a strong no. I'm just not convinced by these code generation or image generation tools particularly. I have to say, no doubt there will be a slight pushing in. And you could argue, right? Like, so the classic mistake for somebody like me to make in this situation is to say, well, that's never going to take up my job. So, just go away. It'll never do it. But I tell you what I think. I tell you why I think the real limitation is here. It just isn't where the effort is largely expended for real world developers or designers is the bit that they're demonstrating. It's like you know those logo generator sites. You ever seen those where you got a startup and you want a logo and they exactly, and they're rubbish, right?
Yeah.
But this will be very good for that. They will be very good at doing that. But that logo generator sites haven't replaced designers. They've replaced one tiny bit, which is the kind of not low value, but a bad design can be done by an algorithm, but a good design can't be. And I think it's just I actually the Star Trek computer. I don't think the Star Trek computer would be able to eliminate a good designer either, which for me is just shorthand for like infinite compute, because it's just not what.
Let me ask a different way though, because you've gone to a different place with the Star Trek computer, because I think we would think the Star Trek computer is super awesome, right?
Yeah.
At least cliche wise. But I saw a tweet from Paul Graham about a month ago or so on this, and he said a lot of developers, something along the lines of, I'm going to get this wrong, but just from memory, something like a lot of developers, basically your position, think that GPT-3 is just like a toy. It's just bullshit. It's not really strong. Does that remind you of something? And I think with that tweet, he's obviously, well, for me, he's kind of hard. He's referring to Clay Christensen's kind of disruption theory stuff, saying that the most disruptive technology at the beginning always looks like a toy. It always looks like something that won't be good. So what do you think about that?
I mean, I don't disagree that it could disrupt that part, which is give me a button that looks like a watermelon. But that's not where developers spend most of their time. They spend most of their time, probably the majority of their time, figuring out why the machine doesn't work properly, which is problem one.
And let me ask another way then. I'm just trying to explore this even further. I boringly probably just agree with you, to be honest. But how about this then, following twist? Do you think that, again, similar to what we discussed with NoCode, do you think this kind of technology will empower people who are not developers, but are, have a desire, or can at least articulate some kind of desire to be closer to what developers can output, but don't have the chops or don't have the training and have a different job, but could do with just bashing out something for now? Do you think that kind of, because in a sense that's the kind of no-code conversation we had, or
it is, yeah,
an iteration of that. Do you think GPT-3 is different than other no-code things?
I mean, it has the potential to be more generalized. Like where, if you recall in the no-code conversation, where it gets frustrating always is that as soon as you wanted to do something it can't do, you're like, that's really annoying. So it has a potential to be far less bounded in that regard. Look, I feel like I'm being a bit defensive. I don't mean to be defensive. My realistic answer is I just think we spend an awful lot of time as a developer not doing the coding bit, whereas everybody thinks that's what you spend all the time doing. So maybe it'll replace all the coding. I mean, goodness knows. There's a joke in developers, for engineers that say you can't write 10 lines of code without writing a bug in it. I mean, that's just, so we're not that good at that writing the code bit. So maybe it'll replace that. I do have a worry. If I have one worry, is that the type of stuff that GPT-3 will be very good is at doing the type of stuff that, novice coders who come out of a boot camp, they're basically at the start of a journey, and they have to go on a journey, and they're now prepared and able to go on the journey, and that's really what they get from it. They don't get production ability, and so this is the common concern of AI across lots of domains. This is just a specific example of it, but you'll see the same thing in law, etc. If we take away the low-hanging fruit jobs, or the relatively more junior jobs, where's your path to more expertise if you're not doing this? That would be a concern I have.
Yeah. I think I see that. let me ask a sharper version of that question then. So if the coding part is not really the part that needs to be fixed, or if that's not really where the sort of where the gains can be made, what is the part that where could gains be made for developers or engineers?
Oh, that's yeah. Yeah, I mean, so the job of being a developer is systems thinking, so preparing how you're going to solve the problem and understanding the problem, and then executing on it, which is the bit we've talked about, and then you spend an enormous amount of time figuring out why it doesn't work and fixing it. And that's just that's an explosion of complexity problem. So we don't do things like show me a button that looks like, I mean, we do that, show me a button that looks like a watermelon, but that's in the context of a very convoluted, complex stack. Maybe what we'll get is a better stack to sit on top of that's more robust, because when it breaks, it's just very hard to fix. That's the truth of it. So maybe helping us fix things quicker is where the real value will come.
Do you think there could be some kind of optimization of the system towards understanding all of those bits? Well, let me elaborate. I'm forever caught in a trap here of the simultaneous uniqueness of human thought, and then the very opposite of that the problems that we do look to solve very often are very, very similar. And sometimes I think that human experience, or being, you spoke about, developers coming out of boot camp and not, being at the beginning of a journey. And sometimes I think that journey, being further along that journey, being very far in that journey, frankly, that whole process could be taken apart. And if you look at it quite sort of brutally or nakedly, it looks like an optimization process that was about seeing patterns and was about doing probably a bunch of very few things better and better.
Yeah.
And do you think you could attach yourself to that?
My view is that's true in software developers as it is true elsewhere, but software development is already solving this problem not with AI, it's solving this problem with frameworks and tools we already have a kind of virtual stack where we reuse other people's things. AI is an odd one within the context of that, because you can't necessarily know in many cases how the AI has decided what it's decided, and that's the antithesis of the thought process that drives most engineering, is that you're trying to work out how it works. So putting large blocks or large black boxes within your block diagram, that I think is probably going to be semi-problematic. But I tell you what, let's kind of, I want to come to your side of the argument. So there is an area where I am worried about this taking jobs, and that area is in AI. I think GPT-3 points to a much.
I think I know where you're going.
Yeah, it points to a much bigger question. So let's say today the job of a data scientist, right? That let's say if GPT-15, right, becomes amazingly good at what it's doing, take us back to how it works. How it works is you don't retrain the model. You basically do few shot learning. So you have to become very, very good at that job, which is priming it. And then people, the argument is you have to be good at priming it and then debugging the output. I mean, like, good luck debugging the output. That's going to be I don't know how you debug the output, but basically you can think of it as an iterative cycle where you give it some priming, it produces an okay result. You give it other priming, you produce another type of result, which is better. So the people who are good at that priming will become the knowledge workers of the future for transformer-based models, if that's what we have, right? Mm-hmm. But let's compare that to what we've spent the today time investing in. It's a much more statistical heavy, data processing heavy role, a data scientist, than that role describes. This would be the worry I'd have, we may have made a jump that wipes out the skill set of advanced data preparation. It's like GPT-3 is directly hooked up to the fire hose of the internet rather than sipping carefully prepared bottles of Evian. And a lot of the data scientist jobs, they work in the bottling plant, right? We're going to take it away. So that would be one concern that I genuinely have. I mean, I don't know what you think about that.
No, I think that's really interesting, and I think I see what you're talking about. I think that could be something that would have. I think humans could adapt to it quite quickly as well. Let's be honest. But yeah, for sure, I think that's an angle where this could do something faster than we think it could. And the bit that I find so interesting about OpenAI's approach to this is that, and I think this was deliberate, and this is maybe where this sort of Sam Altman style thinking comes in. Something we haven't really spoken about an awful lot is that GPT-3 is task agnostic.
Mm-hmm.
So because of that, and we've hinted at it, but we haven't sort of called it out, with that terminology. I think that means it could be fed into, every vertical, essentially, or become, again, as you were sort of hinting at earlier, part of a new stack, and it could sit, all the way through the stack almost, right? It could be right at the top of the stack, in the middle of the stack, at the bottom of the stack, be kind of ubiquitous, and that's something I think is really interesting. Matt, can I ask you something really silly? I don't know how to articulate this, and this might be woefully stupid, but when we first, as humans, made calculators, I believe it's the case that calculators were made to second guess human calculations. So, at first humans calculated, and we developed, the abacus and a whole bunch of clever stuff to aid with calculation, right? But the onus, the cognitive load was on the human. And then we made these tools, like a calculator that sort of came up with the answer. And at the beginning of that journey, we would then question the calculator, right? Mm-hmm. So, so human comes up with a thing, calculator double checks it, and then human double checks the calculator. And I guess we do a kind of version of that still to this day. But that, I don't know what if we talk about cognitive loading, if we put that in a percentage number, I wouldn't know which, I think, obviously before calculators came around, it would be 100 and then, 0. And then calculators came along, and let's say it was 50-50, but then it was, I don't know, 33, human calculator, then human checking again. But now it's like human 0 or something, or very little, and then calculator 90 plus, shall we say. Mm-hmm. Is there an analogy to be drawn from that kind of thing towards what GPT-3 could do for coding?
Well, yeah, I mean, we already have lots of things that try to do that job already for us. So we have.
But this is different, right?
It's not so different. If the task is writing the code, it's not so different than something that does syntax highlighting and as you type static analysis to say here's a mistake. Like if it's just you really want it to be doing generative work rather than policing work. If that's what I take from your.
But that's what I mean. Like at the moment what I was trying to get is that you're saying, hey, we've already got all these policing tools, and I'm saying this is different. This is a generative tool, and the human will be doing the policing. That's what I meant with the.
Yeah, I don't think they'll be doing. I genuinely don't think they'll be doing the policing. I mean, already the story is in the world of development is that you probably write stuff and you come back to it like a month later and you're like, what is this garbage? Who's the idiot that wrote this? You check it's actually you. We don't do that well. We don't do the policing of how it's doing. What I think will happen is people are inherently lazy. If it gets pretty good at doing this, we'll just not care. We'll just say, fine, it does it. We won't even look at it. And that's one of the concerns. I mean, if you flip it all the way back out of coding to the sort of general proposition, it's inherently encoding a ton of scary biases. I mean, if what's on the internet, well, the internet's full of pseudoscientific textbooks, conspiracy theories, racists, manifestos of people who are very odd. they're all there in the corpus that fed this. There's no way that it is in anything other than reflecting the biases that's in human output. And that's backwards looking culturally by definition. So even if we wanted to be better than it currently is, we couldn't do it without putting some other layer on top to teach it kind of social norms that we want it to learn, rather than just the ones that came from the text. But do we want it to do that? I mean, that's kind of like weird, gatekeeping. That it's not weird, it's gatekeeping, right? And gatekeeping often turns out to be more of a concern than the alternative. So you could filter it out for what you choose to be sort of acceptable. But really, are we going to do that? That for me, the big question of, as soon as you start generating anything kind of without controls, whether it's code or whether it's speeches or whether it's tweets or whatever it is, it's instantly raising. And this is why OpenAI being behind this is good, because they at least think about this. I'm not saying they're good at it, but they're at least thinking about it. Once you start generating that stuff, I think it is, I don't know how to solve that problem. I mean, what do you think?
Oh, I don't know. It's really, really hard.
That's a hard one,
It's, you can look at it. You can look at it through kind of Greek philosophy, but you could also you look at it through Hegelian philosophy, where there's a statement that everything that's actual is rational and everything that's rational is actual. I guess that's another whole podcast. But yeah, I think it opens up loads and loads and loads of questions. I think we probably should bring this to an end now. I think we'll talk about this again probably, and I think GPT-3 is really interesting, more interesting than other things. I think it's a big leap forward, and it's something I think we'll definitely keep tabs on. What do you think?
Yeah, I think so. I mean, if you had to make me make a bet just now, I don't think the transformer architecture is ultimately the end game for natural language prediction. But it's an interesting stepping stone. It's starting to it's hinting that maybe general intelligence isn't anything other than sounding coherent, and therefore we can just go down the sounding coherent path. I mean, they actually call out in the paper that even though they increased the parameters by 2 orders of magnitude, it's not any better than GPT-2 at kind of discerning the actual meaning of a sentence. It's just better at sounding coherent. So my sense is that another model will come along in a couple of years, and it will blow us all away on some other dimension that's, that we feel is more human than this currently is. But having said that, there's no doubt at all that this potentially takes out a ton of costs if you've got any kind of linguistic processing task for a startup. And you talked about the stack a little bit there. I mean, I think to myself, is this more like a Photoshop kind of equivalent where it's just brilliant at creating fakes and generating content, or is it more like an operating system which we develop apps out of, or is it actually just the electricity that spawns a whole myriad of new capabilities that we haven't thought about before? And I think it's exciting to see where it goes, but my sense is we'll have another step before we get anywhere totally amazing.
Oh, for sure. But I think it's a huge emergent step.
Absolutely.
Cool. Let's leave it at that.
All right,
Thanks
nice.
very much, man. Take care.
Catch you there. Bye.
Bye.
Thanks for listening to Startupification. If you have any feedback, you can contact us at startupification.fm/feedback. And if you want to support the show, please consider writing us a review on Apple Podcasts. It's a small thing you can do, but it really helps other people find the show. Special thanks to Ollie Littlejohn, who edited and produced today's episode, and to Stephen Coleman, who wrote and performed our music.